The great thing about the quadratic formula is that you can use this to solve all quadratic equations. So quadratic means degree 2, that they can be written in this form. And the equation does have to have 0 on one side, just like the factoring method. And this equation will have up to two solutions. So what we're doing is we're going to solve for x, which is the variable in the middle term. Whatever variable's in the middle term, that's what we're solving for. And the way that the formula works out is you take negative, so the opposite of b, plus and minus the square root of b squared minus 4ac all over 2 times a. So the first thing you probably want to do is recognize what a, b, and c are after you get 0 on one side, and then plug those into the formula. So we're going to solve the same equation that we solved with the factoring method so that we can check those answers, make sure they're true. And we're going to use the quadratic formula. So first thing, 0 on one side, check. Second, let's identify a, b, and c. So a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the constant term. Okay. We're solving for that middle variable, so in this case that's x. So x equals the negative of b plus and minus the square root of b squared. And always put that in parentheses to make sure that it's going to be positive all the time. Minus 4 times a times c. All over 2 times a. Okay. So the first thing that we do then is to simplify what's under the radical, because there's a lot of stuff under the radical. So we'll do the squaring. 9 squared is 81. And then count how many negative signs there are. There's only one negative sign, so that means that the product will be negative. If there's 2 negative signs, then that's positive. If there's 3, then it's negative again. So count the negative signs is the negative signs. That's my hint for you. It will help you with that sign of the product here, because that's where a lot of people make mistakes. So then we'll just multiply. 4 times 2 is 8 times 10 is 80. And in the denominator, 2 times 2 is 4. So still simplifying under the radical, 81 minus 80 is 1. And then we can take the square root of 1, which is 1. And since these are all integers, we're going to go ahead and separate and find answers. So negative 9 plus 1 over 4, that's one answer. And negative 9 minus 1 over 4 is another answer. So negative 9 plus 1 is negative 8, divided by 4 is negative 2. So that's one answer. And negative 9 minus 1 is negative 10 divided by 2, which simplifies if we divide a factor of 2 from those, then that leaves negative 5 halves. So we have these two answers to this equation, a negative 5 halves and a negative 2. And that's exactly what we found from the factoring method. So that verifies that this quadratic formula gets us the same answers that we would if we were able to factor. But we're not always able to factor, so another example here, 2x squared minus 6x equals 1. So first I need to get 0 on one side. So I'm going to opposite that 1 from both sides. So on the left, 2x squared minus 6x minus 1 equals 0. Okay, so I got that 0. And then I'm going to identify a, b, and c. So a is the coefficient of the x squared, b is the coefficient of the x, and c is the constant term. All right, I'm solving for that middle variable, x, equals the opposite of negative 6, so that'll be a positive 6, plus and minus the square root of negative 6 squared minus 4 times a, which is 2, times c, which is negative 1, all over 2 times a, that's 2. So we have to simplify what's in the radical here. Okay. Negative 6 squared is 36. It'll always be positive. Then count the negative signs. There's 2 negative signs, so that means this will be plus. 4 times 2 is 8 times 1, so 8. And in the denominator, 2 times 2 is 4. So, still under the radical, we need to add together 36 plus 8, that's 44. And the square root of 44 is not going to be an integer. So let's simplify that. Let's do up here, square root of 44. So that's 4 times 11. So we do have a square root of 4, which is 2. And the 11 is left inside the radical. And since this is a rational, I'm not going to separate the terms because I can't actually add an irrational number and a rational number together. They're not like radicals. So what I'm going to do instead is I'm going to look in the numerator, and there's 2 terms, right? There's the 6, and then there's plus and minus 2 root 11. I'm going to factor out a factor of 2. So 6 divided by 2 is 3. 2 divided by 2 is 1. And then I can divide a factor of 2 from the numerator and the denominator to simplify this irrational expression. So that leaves 3 plus or minus root 11 over 2. And that is as simple as that gets by hand. If you want to separate those because you have to write separate answers, then that'll be 3/2 plus root 11 over 2 and 3/2 minus root 11 over 2. Example 3, we want to solve this equation by the quadratic formula. So this is equal to 0, check. Except a is 1/6, b is 1/2. Yuck. I do not want to work with fractions. Do I have to? No. This is an equation. I can do whatever I want, as long as I do the same operation to both sides. So I want to clear the fraction. I don't want to work with fractions. So let me clear it up. I need the least common denominator of all denominators. So between 6 and 2, least common denominator is 6. And then I'm going to take that and multiply it to each of those terms. So 6 times 1/6, 6 times 1/2. Don't forget all the other terms too, 6 times 1, and 6 times 0 on the other side. So that 6 is going to divide completely for the first term, leaving just 1x squared. That second term, 6 divided by 2 is 3x. The last term, 6 times 1 is 6. And on the other side, 0 times anything is still 0. So that's what makes this a good method to use. We've cleared the fraction, but we still have 0 on this side, so we're still good to go. Let's identify a, b, and c. A is 1, b is in front of the x, that's 3, and c is the constant. So now I can solve for this middle variable, x. Negative b plus and minus the square root of b squared minus 4 times a times c, all over 2 times a. So let's do some simplifying in that radical there. 3 squared is 9. There's 2 negatives, so that's plus. 4 times 1 is 4 times 6 is 24. And in the denominator, 2 times 1 is 2. So now we can add together inside of the radical. 9 plus 24 is 33. And 33 is 3 times 11, so there's no perfect squares. There's no 2 factors inside of that. So this is as simple as it gets by hand. Again, you can separate this into negative 3 halves plus root 33 over 2, and negative 3 halves minus root 33 over 2 if you need to separate those answers. For number 4, we want to solve this by the quadratic formula, and this is not equal to 0. And since my x squared is negative, I'm just going to add 4x squared to both sides. So I'll move it to the left side. And I'll also have to add 4 then to get 0 on that side. Okay. So on the right side, that's going to be 0. On the left side, let's start with the x squared. So 4x squared, then there's x, and then plus 4. Okay. So I want to identify a, b, and c. A is in front of x squared, b is in front of x, and c is the constant. So that I can solve for that middle variable. X is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So I need to simplify what's inside the radical. 1 squared is 1. There's 1 negative, so that's negative. 4 times 4 is 16 times 4 is 64. And then in the denominator, 2 times 4 is 8. So we can go ahead and add together in the radical. 1 minus 64 is negative 63, which is going to be a not real number, and that's okay. This is just theoretically what is the solution. It's not a word problem, so let's simplify that root negative 63. We know there's going to be root negative 1 for I. 63 is 9 times 7, so there is a square root of 9, which is 3. The square root of negative 1 is I. And the 7 is left inside the radical. So that will be 3i root 7 all over 8. Since there's no common factors in the numerator, I can't simplify this. This is as simple as it gets. But again, if you want to separate, that's a negative 1/8 plus 3i root 7 over 8. And a negative 1/8 minus 3i root 7 all over 8.